Thank you. Let's start with a story here. Picture this, a Squid Game level global launch. Massive hype, traffic projected to blow past peak. So we do the responsible thing. We declare a blanket deployment freeze. Nothing ships, so nothing breaks. Teams keep building though. Features, performance fixes, capacity tweaks, it's all stacking up behind that freeze. Launch day hits, traffic ramps up, and then one region starts to wobble. You're seeing errors climbing, latency spiking, and we realize there is a capacity improvement we made last week exactly for this scenario, which is sitting behind the freeze. So we are riding the launch with last month's capacity profile. And then fast forward, the freeze lifts, and we push a huge batch of changes. If something breaks, your suspect list, everything. Well, show of hand, who here has been in a no one deploys for a week kind of freeze? Oh, all of you, excellent. All right, hi everybody, I'm Prachi, I'm an SRE in the security engineering audit at Netflix, mostly focused on making changes safer without slowing people down.
And I'm Sandhya, technical program manager at Netflix. We are the people who are extremely averse to risk, but also hyperallergic to stopping our engineers from shipping. So in this session, we'll share about how we think about risk and how we avoid blanket freezes. So welcome to our talk on Beyond Blanket Freezes. We'll talk a little bit about how we went from no changes allowed to allowing some changes during some of the most critical events at Netflix. We'll spend the next 15 minutes talking about what's wrong with blanket freezes and how they typically backfire, how we replaced it with some risk-based classification and signals. We'll talk through some resiliency tactics that makes the deploys safe. And finally, how we automated the bypass so teams can ship when it matters and not have to keep asking for permission. So hopefully by the end of this talk, you have at least 3 concrete things you can try within your own organizations.
All right, let's start with what's wrong with blanket freezes. We used to have what we like to call as quiet periods around big events. I'm talking major title launches like Stranger Things, Squid Games, global product pushes, live events. On paper, they sounded great, but we kept seeing the same 3 problems. Let's dive into those. First, innovation slowdown. Teams don't stop building during a freeze. They just stop shipping. So the work piles up. People either rush to squeeze in things before the freeze, or they're trying to catch up right after. Either way, you get chaos instead of progress. That leads me to the risk pileup. The changes that are ready and sitting behind a freeze, the moment you lift that freeze, you deploy a massive batch. If something breaks, as I said earlier, your suspect list is everything we just shipped. And lastly, operational pain. A hard freeze makes SRE, security, release engineering, they turn them into gatekeepers. This one is really important, can we please ship it, kind of goes through them. But there's a 4th problem that we don't always talk about, and that's security debt. When you freeze changes, you're not freezing security. A critical patch that's ready to ship, it's sitting there. A compliance requirement that probably needs a config tweak, also blocked. So you end up in this weird state where you're trying to be safe by freezing, but you're actually making yourself less secure.
And from an audit standpoint, when you do eventually deploy that batch of 200 odd changes across 50 services and something goes wrong, you can't easily answer which change introduced that vulnerability, or did we actually test this security control? And that's a serious compliance problem waiting to happen. So Prachi, it looks like the freezes didn't remove the risk, it just rescheduled it and concentrated it.
That's exactly right, Sandhya. And this kind of risk is harder to manage, operate, and mitigate. So before we dive into how we solve this problem, let me ask you this, Sandhya. As a TPM, what scares you most about these big post-freeze deploys?
Honestly, I think it's the needle in the haystack. When we have no idea of the thousands of changes that we have made across hundreds of our services, we know that will come to bite us. And you very well know at our scale, when something breaks, it's visible and often breaks loud. So for a quick show of hands, how many of you have been through an aftermath of freeze deploys and that has created some risky behaviors? We see you. This is definitely a group therapy session. But the good news is, acceptance is half the problem. We too realized that the freezes weren't working for us. In reality, our systems weren't all playing the same role. Some were in front of the customers, some were buried way back deep in the background, and some were mainly for our engineers to make their lives easier. So in order to solve this problem, we started asking a different question. What if we actually tuned our controls to the real risk of each service? And instead of freezing everything the same way, that's where this idea of risk classification came in. Isn't that right, Prachi?
Exactly right, Sandhya. And we based our risk tiering based on three simple things: impact on customer experience, blast radius during a critical event, and what is the acceptable risk threshold for us. Once we had data for those three things, we stopped treating everything the same and turned it into a tiering model that our teams could use. Let's dive into that. At the very top, we have Tier 0, or critical services. If this breaks, the user absolutely feels it. Think play button, signups, payments, logins. Right behind Tier 0, we have Tier 1, which is our high-impact services. These are the services that are tightly coupled to those core experiences. If they misbehave, it might not be as obvious as the play button breaking, but it still hurts the user quickly. Then we have Tier 2, or medium impact services. These are important platform and infrastructure services where the impact is indirect or delayed. If they are degraded for a short time, users may not notice immediately. And lastly, the low impact one. Think of internal tools, low blast radius services, where a hiccup is probably an inconvenience for you and your engineering team, but it will not make a front page incident. And those are the ones which are absolutely safe to ship. And that's where we really preserve velocity. So coming back to the core idea, not everything should be treated like the play button. Classify risk, but under a blanket freeze, we were not doing that. Think about your own stack here for a second. How many services would actually break the user experience if they go down? And are you really applying the same controls to them as you are to your internal dashboards?
Once we had this classification, I'm assuming we stopped asking, should we freeze? And started asking, which services we need to be more strict and which can keep shipping?
Right. The higher the risk, the stricter the guardrails. But in addition to tiers, we also needed to know for a given service, for a given change, how risky is this right now in the moment? We wanted to move from gut feeling to a few simple risk signals. And these are the 4 core risk signals we lean on. Deployment confidence. How confident are you with your pipelines and the embedded reliability patterns? Test signals, whether changes have passing tests and enough code coverage. Change type, the scope and nature of the modification you are making. And lastly, historical behavior. How has this service and this change behaved in past during critical events? So instead of a blanket freeze that says everything is banned, our model gives us nuanced answer. Service X with this change at this moment is low, medium, or high risk. For example, take an internal UI tweak, a config change maybe. Tier 3 service, great deploy history, passing test. Under the old blanket freeze model, it's blocked. But under a new model, the signals read that change as low risk and let it ship. Keep in mind, blocking safe changes is essentially punishing the wrong people.
So Prachi, once you started rolling out these signals, what surprised you?
Oh, when we actually looked at the data, it challenged a lot of our assumptions. Some services felt absolutely scary, and others had great deploy hygiene. So if you're starting from scratch and can only instrument 2 signals, use these. How often do deploys fail? And if they fail, what's the blast radius?
So moving to our next section, which is all about empowering our teams and letting them keep shipping, even during critical events, without putting availability at risk. We've got tiers, we've got risk signals. We know what changes are safe to make, but we still don't hit that deploy button. Would you say we are paranoid in a good way?
Absolutely, Sandhya. I feel paranoia is the middle name of an SRE. For building resilience into our framework, we basically lean on 3 primary tactics. Canaries, which is essentially can be used to verify that changes in your code or configuration will not cause deviations in performance behavior. So instead of flipping a giant switch, a tiny slice of traffic sees the new version. We watch metrics and error rates, and only then we roll out to wider audience, especially for high-risk tiers. Then comes regional staggering, which is essentially deploy region to region. Deploy to a region, evaluate, and move on to the next one. So if one region breaks, it does not turn into a global incident. And lastly, synthetic tests. We make sure our critical user journeys are well tested. Think of, can my users press the play button? Can they log in? Can they sign up? 3 simple tactics, but together they turn, we hope this works, into, we know this works.
So now we have tiers, risk signals, and tactics. So how does this all come together in practice? Who can bypass these freezes? I know the intent is we don't want to become bottlenecks. Did we end up automating the bypass?
Excellent question, Sandhya. And yes, we did. So we have this simple formula up there on the screen. Bypass decision is essentially equal to the result of the 4 core things we discussed: event type, service tiering, risk signals, and resilience tactics. And we use something we call as risk-aware launch rubric. Think of it like a scorecard, the one you see up on the screen. It takes everything we discussed: event type, how critical the moment is for us; service tier, how close you are to the core experience; risk signals; and lastly, resilience tactics, and turns it into a clear, can you bypass the freeze decisions for us. So if you meet the criteria for your tier and event, the rubric says, yes, you can ship. If you don't, it blocks you and it kind of nudges you. Hey, add more guardrails. The best part is, this isn't a manual hallway conversation. It's wired into our deployment pipelines, so the system applies the rubric the same way every time, consistently, safely, and data-driven. So it's about understood risk, engineered mitigations, and pipelines that enforce the framework for us. And that brings us to our feedback loop. Sandhya, what do you think about that?
Yeah. Ultimately, we want to be business enablers. So the real question is, do we know if the system is actually working? After big events, we don't just say, that's over, and move on. We run post-event reviews that look at the whole picture. What worked, what broke, what was just unnecessarily noisy or stressful. Then we do a signal and tier tuning. Did a tier 2 service behave like a tier 0? Maybe it's mistiered. Did our risk signals fire too often or not enough? Do we need to adjust thresholds? And finally, we update the playbook and the pipelines. If we learn that a certain type of change really needs canaries or synthetics, then we don't just write it in a document, we actually wire it into our CI/CD flow. The goal is that after every major event, we leave the system a little smarter than before and not just tired humans. Time to wrap up. Take us home.
All right, so here are the 3 main takeaways which we want you to leave with. First, make risk-based decisions. It's not freeze everything or ship everything. It's knowing your services, understanding the trade-off, and choosing the right level of risk. Then, automate your risk signals, track deployment success rate, test coverages, and from a security lens, maybe add a third signal. Has this change been security reviewed? Those 3 indicators cover a lot of ground. And lastly, design for resilience. Canaries, regional staggering, real-time monitoring. These aren't just nice to haves. They are how you detect issues early before they turn into global incidents.
And listen to your teams. Their feedback is data. Use it to make the system easier, safer, and faster over time. Start small. 2 risk signals, 1 resiliency tactics. Learn, expand. You don't need a multi-year platform rewrite. You just need to get started. Thank you.
All right, thank you, everybody.